Hello everyone, I am Konrad. I work here at MagicWorks. Today I will be speaking about how to optimize render calls and latencies of native animations. I think Paul has given a really nice introduction on sort of how pan responder sort of solves the problem. I think this is a really similar subject, which I think is great in terms of how we can take it further and solve some of the problems possibly. This is a lot of the work we've been doing is engineering performance on low performance devices such as the ones we manufacture ourselves. So just to give you some idea, we manufacture our own devices. We also manufacture our own hardware to plug into your TV. And it looks like this. It comes with a controller. Just a quick recap on people who weren't here last year in August. The controller we have is basically a point and click device. So you point on things and you click, and that sort of is a touch event on React Native. The way we run React Native is by using Android and by using Android source code and flashing it on our hardware, meaning that we're able to take full power of React Native on our hardware. About the application itself, it's 16 months in development. We've released to production in February this year. Currently, we are actually using React Native 56, but we also have a branch that works with 59. We just don't really find any necessary things that we actually need from the 59. But we are able to use 59 as well. This is how the app used to look in August 2018. It works in full high definition, so 1080p resolution on the TV, which is a bit unusual for the application. This is how it looks now. So this is a very different way of designing an application, because you're not designing it for a small screen on a mobile device, you're designing it for a large display, which is a whole new experience and a whole new level of design, where usually on a React Native app on a mobile you would only fit roughly 6 or 7 buttons that you would press, but on a TV screen you would really kind of have more than a few buttons to actually interact with. So for us, the highest sort of challenge was actually how do we scale, how can we present a lot of sort of UI and not run into memory problems on a low-powered hardware that we have. This is a sort of a stack that we use. It's nothing really, it's pretty straightforward. It's quite simple and very similar to any other React Native app. I'm not going to go through them, but you can get an idea. The overview of the talk will be part 1, how do we achieve faster animations and the latency to start the animation, improving the render time, so how long your component takes to render, which actually by improving that time you also reduce the number of frames that will be dropped during the animation. And part 3 will be avoiding unnecessary renders, which is also makes the animations a lot smoother. A quick recap on animated library. You simply create a new animated value. I think a lot of you have used this before, this API, which is you create a value, you start the animation, and you simply render a component, for instance, an image with an opacity using that animated value. It's a built-in React Native API, so everyone should be familiar with it, but it's straightforward. So how do we achieve faster animation latency? What we've created is not a new concept. It's been previously done by React Native Interactable by Wix. They've done some work, however, their work is very limited to dragging elements only. It works if the animation is initiated from any user input event, which means whether a scroll event or a touch event or any sort of event that may come from the platform you're developing the app. So for instance, on a TV, you get focus events. On a tablet, you get touch events. On a sort of web, you get a hover events. So it really depends on your platform, but we've achieved ability to do it for all those events, because in our case, our application needs to run on most platforms, and we want to be able to flexibly and maintain the code in an easy way. So it's a new concept in our case because we want to make it general purpose, not just for dragging purpose. So we are able to take it further than just dragging the elements. This is sort of how it currently works with React Native. You have a touchable opacity, which gets on press event. There's a bridge between the component and the native side. Now every time touchable opacity is mounted over the bridge, the initial props must be sent over the bridge, which to the React view, which is implemented either on Objective-C or Swift or Java. And whenever that view receives any user input events, the information about the event is sent back to the JavaScript context, which could be either on press or on hover event. And then the component makes a decision of what to do, and very likely, and in many cases, the decision is to start the animation using the native driver to make sure the animation is happening on the native side. As you can see, the message is being sent across the bridge is sort of back and forth, where event is being sent and then the event is being sent back to start the animation. Our solution is basically writing a new component which solves the problem. And what we do, we send the information of the animation that should happen to the native side before the animation happens. So for instance, we know what the hover animation may be. We know what on-press animation may be. So if you think of material design, which is sort of the Google's design, that when you press anywhere, the sort of animation sort of expands, sort of like a pulse animation. That animation, we already know how long will it take and how it expands and how it animates before the user presses the click event. So we're able to take advantage of sending the information over the bridge before, and the animation would start actually the next frame as soon as the event happens without sending anything over the bridge, which reduces the latency of our animations. Just a quick example how we're doing it. We're able now to use pure components as opposed to regular components. In our case, we're able to create the animated value, which in this case, it defines a pressed progression. So when you press down a component, it's animating to 1, meaning it's been pressed. And when you unpress, it goes back to 0, defining that that component is no longer pressed. We don't have to animate the value. The native side will animate the value within its own context, within its own thread. There's no need to send anything over the bridge. And we're able to take advantage of simply telling the native side which value to animate, and the native side will do it for us whenever the component is being pressed down or pressed up. We're able to define the easing and duration of how long it takes, which means in most cases when you hover things or when you press things, the animation is pretty much always the same. And in this case, this component actually is shown on press, which you may be familiar with when you receive let's say, a picture on Snapchat. When you press down, the image sort of shows up, and when you release, the image hides. So you can only see it one time. So this is a simple implementation of sort of a Snapchat sort of feature of being able to see an image only when you press down. You can see we're setting the opacity of that component to the progression of the pressed. Now that's not a simple example. We're also able to recreate touchable opacity in JavaScript without sending any events back and forth between the bridge and the JavaScript side. The name of the component doesn't really matter in this case because it's more about the concept of what we created. In our case, we call it the magic view, which allows you to define which animated value to animate, what is the pressed animation, what is the pressed animation out, because in touchable opacity, when you press it in, the component kind of fades out instantly. So in our case, the duration will be 100 milliseconds. And when you press it out, it usually takes a while for it to fade back out, that it's been unpressed. So that takes 600 milliseconds. And you can see we've binded the opacity of the hover using between 1 and the active opacity of a touchable opacity, which is an existing prop of touchable opacity. So if you've used previously touchable opacity component, you should know that there is a active opacity prop which you can define of what is the opacity of the component when it's pressed down. In this example, we're able to recreate the animation of touchable opacity without doing any messages over the bridge, and being able to create it and define all the animations in the JavaScript without having to write a native component for different platforms. In our case, because we have a controller, so we have a hover event where you can hover things on Android TV and on any other smart TV. On a tablet, you would have a pressed event, and on an Apple TV remote, you may also have a focus event because you focus things, you don't really hover things. So in our case, we wanted to have a single code base to be able to achieve defining those 3 different animations, which is the progression of a component being hovered, progression of a component being focused, and the progression of a component being pressed. And we're actually able to create a component called accessible view, which means anything that can be accessed has a different property on different platforms. So for instance, on Android TV, we're scaling the component based on how much has been focused. So on most TVs, whatever you focus kind of zooms in towards you because it's been focused. We don't want that behavior when it's using a touch controls, because you're not really used to things zooming in when you press them. You kind of expect them to kind of fade out, which is why we control the opacity based on hover and pressed. So when you hover things, you expect things to kind of fade in more, which is why we're controlling the opacity of a component between 0.7 and 1, which means when you hover elements, they kind of fade in more. And when you press them, the pressed interpolation means that it subtracts amount it's been pressed down, which it feels like it's been pressed down. Using this way, we are able to achieve great performance because we actually don't have any latency of being able to create those animations, and we can actually, from a low level and from a ground up, be able to define the components that we need and how they animate in our case. A little example of our app and how we use the hover events. Whenever you hover a card, they simply tilt in kind of 3D space, and they bring up a bit of opacity as well. So in this case, it looks quite nice, and we're able to do it, defining the whole animations on the JavaScript without having to worry about the platform or without having to worry about how it looks. So if you would be using this on an Android TV, you would expect the cards to actually zoom in a little bit, which is actually the pattern that Apple TV kind of recommends. So we want to be, whereas on our platform, we are kind of tilting it and kind of changing the opacity. Part 2 is improving the render time. So we wanted to make sure the animations don't drop any frames. It's a new concept we haven't seen before. In simple words, we memorize all the animated interpolations. So it usually can be solved when you interpolate any value, and you can put it in a state, or you can derive it or put it in the object values. But we found it very difficult to maintain and manage. We kind of want to keep everything within the render function to be able to define the components quite easily using pure components. This is kind of an example of a problem where you would want an icon to be an image where opacity is being driven by if the element is being hovered or element is not being hovered using the ROXi controller. And the opacity would be 0.7, so 70% opacity when the element is not hovered and 100% when it's hovered. The problem with this is every time you call interpolate function, it returns a new object every time, which means a new animated node is being created, which needs to be sent over the bridge, because the React thinks it's a whole new animation and needs to be updated on the bridge and on the native side. So for us, that created a problem where we didn't want a latency of interpolating an object and having frames being dropped. So a simple solution is to create the animated value and memorize the interpolate function, which seems to work for us quite well. And there's a bit more background of how we solved it. But simply, we were able to create a new object called memorized animated value, which extends animated value, and it returns same object for the same interpolation, which means we don't have to send anything over the bridge if the interpolation is the same. The improvements are that React diffing previous and next render will not apply any commits because the interpolation will be the same. It does not create any new objects every time you call render, which sends over the bridge, and prevents some animations from flickering if the value has changed. So we've noticed that even though there's a lag, there's also a flickering of the animation because the animation may change completely, and we've run into a lot of issues on our device. We'll be sharing the new class we've created with the community to hear any feedback. We think it's great, and we think that we are kind of trying to solve all the issues that React didn't necessarily solve when it comes to animated nodes and interpolations and values. We think it's very useful so we would love any feedback that you may have. Part 3 will be avoiding unnecessary renders. We all have used multiply and add and subtract and divide, which allows you to take two animated values and be able to add them or subtract them. We also knew that animated add and adding for instance, A and B is the same as B and A. We didn't want it to be actually different for a component to render again with a new node. And we actually wanted it to realize that this component does not need rendering because the value of it will be the same before it creates any meshes over the bridge. So I guess the whole work that we've been doing is sort of avoiding any meshes being sent over the bridge between the React native and the native side. So we can implement an existing React method called should_component_update. The question here is how do we compare if one value is the same as the other, if they're actually different objects. So we've used a lodash is equal with, which allows us to compare two objects, and it would compare those two objects the same way as a component in React would compare them. If they happen to be animated nodes, we simply use our function called animated node equal. And if they're equal, we return true, which means the component would not render. Otherwise, we return undefined, which means can we rely on the default implementation of lodash, which is recursive and allows us to compare two objects, for instance, styles or props, to be able to compare it in a simple way that React does already by default. To compare whether two animated nodes are equal, we simply create a couple of conditions which actually cover all the cases that are possible, which means if the first condition is if they are strictly equal, we return true right away, so we don't have to worry, we can exit the function as soon as possible. If the second condition is if there are something else than a value, we simply return false, that they are suddenly not equal. And then we compare their parents, because an animated node could be actually an addition of two values, so they have parents. And for every different module, for different nodes like interpolation, div clamp, modulo, and addition, multiplication, and division, we use different cases to define whether they're equal. This function is also recursive. You can see here that if they have parents, we compare the parents if the parents are also equal, which means that if you multiply two nodes and add additional two nodes, that function will check if they're all equal to define whether a component should render or not render. So to solve this, you can choose using React pure component, which is a shallow compare of props and state. You have a React component, which is a deep compare, and we've created our own component called animated component, which is a deep compare but supports animation nodes, meaning that it will compare any animated interpolations and any other values, whether they're the same or not, to make sure components do not render again. This is how the animated component looks like. It's pretty straightforward, but in the main important part here is should component update, which define whether props are equal or state is equal. And it is not actually creating any overhead because it is recursive, but as soon as the two values are identical, we don't actually traverse through the whole tree. We realize those two objects are the same, and this really kind of creates the moment we've introduced this in our application, we've noticed a significant improvement of performance and all the animations being a lot faster. So So the summary is the Magic View removes all the meshes from the bridge when using native driver animations. The memorized animated value prevents commits after render, means your component does not have to, your animated values do not change the value of the render function, so the render function can be cached and therefore it remains the same across many renders. And is animated equal prevents from component rendering, which is the part 3. Our future work is we love hardware, we love software, we like bring them together. We like React Native of how simple it allows us to define a lot of the concepts that solves a lot of time developing actual product and focusing on the UI and UX. And we love hardware because we like to control building devices that consumers can feel as they're physical and be able to connect them to your TV and listen to music and enjoy the great music that they will want. So our future work is to publish more work on our GitHub page. If you're interested, please let us know what you think. We would like to demonstrate more work such as our animated list component, which allows us to create our own virtualized list for both Android and iOS. And please reach out if you're interested in what we do. We would love any feedback in terms of understanding of if someone else has been doing sort of the same goals that we've been trying to achieve. And thank you for listening. This is a quick demo of how our application looks like, and I hope you enjoy it. So this is what we call the carousel, where you can scroll through different features of the app. You're able to choose the playlist you would like to listen to. And yes, it plays music. You're able to discover different genres of music. You're able to scroll through the different lists and different curated playlists that you may like. You are also able to dive into more sections and navigate deeper through the menus. And as you scroll, you may choose some playlist and look at the preview of that playlist to be able to see the tracks. We obviously have a lot of animations going at the same time because of how big the screen is on the TV. So our use case is very different from a mobile use case where animations are usually a lot smaller, whereas on our screen, if a view slides in, it's a huge thing coming on the screen rather than on a mobile device, which may be kind of subtle and people may not notice a frame being dropped. We also have our own keyboard that we've implemented. So we're able to search through music and be able to search for results of different kinds of music. We also have the latest music available, so you can see this is the current charts that we have in our app, meaning that you can sort of kind of get an idea of all the music we have in our catalog. And that's pretty much it. Thank you so much.